So, hope your weekend treated you well. Uh, Things are going okay. Nice, beautiful weather this weekend. Almost a little too hot still for October. How odd is that? But anyway, so we're going to have our normal stuff today. Like I say, our B days this week is all going to be asynchronous because of PSAT tomorrow, and there's an end of quarter party on Thursday. There's a field trip on Thursday. There's all kinds of stuff going on B days. So B days are not meeting in person at all this week. So look in your Google Classrooms. I'm going to be posting a video from my B day classes tomorrow. I haven't put it in there yet, but I'll have a video for them to watch. And so if any of you have me tomorrow for Algebra 2 or Algebra 3, then it'll just be an assignment. And you don't have to watch the video if you can read through the lesson and understand it. Just make sure you know what you're doing. But I'll have the class video on there in case you need it or anything. So, okay, let's see. Where's everybody at? We've got several of us, but we're missing a good chunk of folks as well. All right, got a few people don't have their cameras on yet. So get the cameras on. It broke still? All right, just send me the email from tech that they're working on it or whatever you got from tech. Because I know when you turn in a ticket to them, they send you something. I don't care, just forward it. Foundations of Programming, 0A. Let's take a look at it. Let's go to our grade screen as usual. And you see you should be done with everything in Module 1. Module 1 should now be done. You should have grades. Well, on the exam, you may have turned it in and I haven't graded it yet because I saw a bunch of stuff turned in over the weekend. So, if you at least it shows you submitted it. That's the big thing. You got it turned in. Here's the due dates. Here's when you turned them in, all that good stuff. So even if it doesn't have a grade, as long as you submitted it, it's just waiting on me to do my part. And I saw several things turned in this week. You see 1.03 and 1.05 was programs. There's still just like 2 people that have not turned in the first program. There's quite a few that haven't turned in the second program, and there's quite a few folks that haven't turned in the Module 1 exam. So you're getting behind. That's not good. That's not good. You don't want programs to stack up on you because it can be hard to get caught up when you got a bunch of programs. So get those in soon before we have to write another program because we'll have one pretty soon. We'll not have one this week. So this week, give you a chance to get caught up if you're behind on any of this. This week we just have 2.01 processing numerical information. That's due this week, October 12th. So let's go back to our activity screen and go down. We'll close the first module now since we're finished with it. We can just close it up and open the second module. Processing numerical information. That's where we're at today. So we'll look at this lesson and see what the assignment is, and then we will move on from there. Let's talk numbers. Well, in the world of programming, there's a few types. Like for now, we're going to focus on 2 of them. We're going to focus on numbers that have decimals and those without decimals. Try to contain your excitement. Please, people. Using numbers in your code opens up a whole new arena of programming. Calculations, right? If we can use numbers, we can do calculations. So this includes any program that involves points, levels, timing, leaderboards, moves, speed, averages, tons more. Everything that can use a number. Numbers just get a little more exciting, am I right? Yeah. Okay, all right. After completing this lesson, you'll be able to identify integers and floating point numbers, understand how Python can be used to perform math equations, and we'll be able to use the string function to concatenate string literals and numeric values. Now, we've talked about string literals, right? That means when I put something in quote in a print statement, I want to exactly print literally what I typed. It's a string literal. So, all right, let's go to page 2 and see what we're going to get into as far as the math. Words or numbers? Well, why pick just one? The world has words, which programs refer to as non-numeric. It means not numbers, right? Non-numeric. It's a string of characters that's a combination of letters, numbers, or symbols that are not used in calculations. Like sometimes we have numbers in non-numeric data. Like you live at 212 South Main Street, right? That 212 is numbers, but we really treat it like it's a string literal because we don't ever calculate it. What's your address divided by 4? No, you don't do that. That's crazy. See, that 212 is like, it's treated like it's letters. It's non-numeric. We don't treat it like numbers. So there's also numbers that we call numeric data. These are numbers that can be used in calculations. So, and programmers work with both. We work with non-numeric data and numeric data. So you remember Ada Lovelace? We talked about her. She was the first programmer back in the 1850s. She was the daughter of a famous poet, and she became an essayist and a mathematician. Without a doubt, Ada Lovelace was both a number person and a word person. And actually, so are you. You use numbers all the time, and you will your whole life. Programmers use numbers in the program code to create your favorite social networks. Those same networks thrive on numbers. How many likes you got, how many followers you got, all that kind of stuff. Think about it. Each post has pictures and words, but the numbers are what matter. Likes, comments, follows, shares. It's all numbers. There we go. We got vacation post over here. Vinny, 1,502 likes. Been out there for 20 hours. In the world of social networking, numbers say almost as much as the words do. In the world of programming, numbers and words both have important jobs as well. So life would be different today if we'd never figured out numbers. Like no internet, kind of different today. No buildings, no agriculture, no medicine. It's all number based. Think about it. A lack of Wi-Fi would be the least of our worries. Of course, sometimes numbers can get pretty complicated. That's why we use calculators and computer programs. Python has a great ability to help us crunch those numbers so we can stay out of the dark ages. All right, let's look at page 3. There it is. Integer, I'm the whole package. Float, I always have a point. These are the two primary types of numbers we're going to be using. Integers, and integers are like 0, 1, 2, 3, 4, 5. Float is like 1.28, 2.9, 3.056. They have a point. There's always a point in there for float numbers. Integers and floats. Now you know what integers are from math. Math talks about integers. It means a whole number. All right. So the first thing that we're going to learn is how Python categorizes numbers. So remember, you're using a high-level programming language to say something the computer can understand. That means you have to use specific terms so Python doesn't get confused. So there's actually 2 different numerical data types, and Python looks at them differently. So int refers to integers. It's a way to alert Python that you're using an integer, which is any positive or negative whole number. -5 is an integer. 7 is an integer. These are positive and negative, including 0. So these are all examples of integers. -12, 4, 0, 234, -7, 68, 99. These are all integers. The other ones are float, which means floating point numbers. Floating, that means any number that has a decimal in it. It can be positive or negative. It can also include 0.0. So these are all examples of floats. It could be a 0.0, 4.64, -234.145, 1.2, -0.45. See, these are anything that has a decimal included in the number is a floating point number. So integer and float. So why does this matter? Well, that's a great question. I'm glad you asked. There's actually 3 reasons why this matters when you're working with Python as a program. One thing is memory. Memory's a lot cheaper these days than it used to be when computers first came out. But still, you may be working with a program that tends to take up a lot of storage space on your computer. Pro tip right here, floating point numbers take up more space than integers. Well, that makes sense, right? That it's going to take up more memory space, because if I just put 8, that takes 1 byte of information. I just need one little place to store 8. But if I put 8.7, now I need to store memory for the point and for the 7. That uses 3 times as much space as just an 8. So if you can use 1 instead of 1.0, you save memory as a program. but sometimes you need that decimal. So precision, you may need to have a specific number that requires decimals. So pro tip, floating point numbers allow for more precision. Like if you're using the decimal 7.5, that's more specific than just saying 7. And you may need to be that specific, especially if you deal with money. Like I got 5 items that cost 7.5 each. I don't want to just use 7. I need to use the 7.5. And arithmetic, you may need to have the correct math. So the results of an integer math and a floating point math are not always the same. Like if we said 11 divided by 5 equals, Python will tell you the answer is 2. 11.5 equals 2. But if you change that to floating point, to decimals, and you say 11.0 divided by 5.0, it's actually 2.2. But here we was limited to just integers. 11 divided by 5 are integers, so it's going to give us an integer answer. And it just cuts off the 0.2. It rounds it down. So you use which number you need, integer or float, depending on what you need it for, how accurate do you need it to be, and that kind of stuff. So let's look at page 4. We'll have some programming examples here in a moment. Python, the calculator. In Python, we often assign values to variables. They can be numeric or alphanumeric. See, alphanumeric is the same thing as not a numeric. The good thing is we don't have to tell Python which one we're using. It can tell. When we give it a number, it knows, or we give it a letter. Let's say we want to create a Python program to help you with your math homework. You might start with something like this in algebra, x equals 5. So it'll take the integer 5 and assign it to the value, the variable of x. Now in Python, the equal sign can mean something different. When you're programming, you use the equal sign to assign a value, right? We said 5 is being assigned to the variable x. Or we could say x plus 1 is being assigned to the variable x. And when we print x, it'll print, first it'll say 5, and then it'll say 5 plus 1, so it'll print out 6 here. Yes, Python can handle this. It will know from your code that you originally assigned 5 to the variable x, and then you're adding 1 in that newest statement right there. And so it'll get a new value of 6 that's printed to the screen. Python also understands common math operations like multiplying, use an asterisk, dividing, use the slash. And there's more it'll do as well. Python will follow the order of operations, right? Parentheses, exponents, multiply, divide, add, subtract. So when you put in math operations for Python, sometimes you need to use parentheses to make sure it does this before that, because it will follow the order of operations. So let's look at some actual programming here with our Python guided activity. And this has 6 slides here, so we'll go through these. Read the code, try to predict the output. Select run program. Okay, so this says hashtag integer arithmetic. Here's our main function. Let's scroll down a little bit. So the first thing it says is we're going to assign integer values. So we're assigning the value 11 to the variable x and 5 to the variable y. And then we're going to print the results. We're going to add x plus y. We're going to subtract y from x. We're going to multiply x times y. And then we're going to take x divided by y. And that's the end of the program. So 11 and 5 being added, subtracted, multiplied, and divided. Let's run it and see what it looks like. 16, 6, 55, and 2. Let's see, 16, yep, 11 plus 5. 6, when you subtract 5 from 11, 55, multiply. And there's that 11 divided by 5 is just 2, which we know is not entirely accurate because 5 does not go into 11 an even number of times, but we're just using integers. So it just gave us an integer answer. So look at the results. Are the results what you expected? Change the values assigned to x and y and try that. Okay, let's give us some other numbers. Let's say x is, let's go with 19. And we'll divide it by 4. How about that? Okay, let's do this. Run program. Add them together is 23. Subtract is 15. If you multiply those, it's 76. And look, it says if you divide 19 by 4, it's 4. It just cut it off because it's actually 4.75, right? Because there's a remainder of 3. But it just cuts it off because it's an integer. It says, I'm only giving you the integer value back there. All right, let's go to slide 2. You can play with this too, guys. You got this on page 4. If you want to go put numbers in here and play with this, you can practice. Okay, here's our second slide, float arithmetic. Now we're going to assign float values. 20.0. That 0.0 just tells Python, hey, this is a float value. It's really the same as an integer, but it's equal to the same value, but we want it to be a float. And we're going to use 2.5, and we're going to do these same 4 operations. We're going to add them, subtract them, multiply them, divide them. But this time we're using float values. So let's run this. 22.5 when we add them. 17.5 we subtract them. When you multiply 20 times 2.5, it is 50. And 2.5 goes into 28 times. Perfectly 8 times. There's no remainder. Let's change this to just like a 3.0. So take 20 divided by 3. Added, subtracted, multiplied, and it's 6.666. At some points, it just rounds it. It doesn't keep putting 6s forever on your screen, or you're probably going to be in trouble there. So we're dividing it. Now it gave us a decimal out to, like, what is that? 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sixes, and then a 7. So we're in 11 decimal places. So, okay. Now let's try this. Let's make 1 a floating value and 1 an integer. So we're experimenting to see what will happen if we 1 float, 1 integer. Will it give us float or integer answers? Oh, look, nothing's different. It gives the exact same answers. Let's change this number just so we know it's doing something. Let's change this to a 7. It still gives us float. As long as one of the 2 numbers is a float, it's going to give all the calculations as a float value. 2.85714285714. So there you go. As long as there's at least 1 float value in the calculation, your answer will be a float value, a decimal. Let's look at the third slide. Oh, they're going to do the same thing I was just playing with. Integer, float. Calculate total cost. So what are they doing this time? They're adding it together. So like if this is, you bought 10 items and they cost $8.99 each, we're going to multiply those together because you bought 10 of them. Count times cost and print total cost with that number that we calculate right there. Total cost 89.9. All right, that's pretty nice. Notice the output calculation. When you mix integer and float values in your arithmetic, the result will be a float for a precise answer. 10 was an integer. 8.99 is a floating decimal. All right, let's look at slide 4. Order of operations. See how order of operations work. We're going to assign num1, num2, number 3. So this must be like test scores or something, right? We made an 85, a 95, and a 91, and we're going to calculate the average. Calculating the average. So it says num1 plus num2 plus num3 divided by 3. So add those 3 together, divided by 3, and give me the average. So let's run the program and see what it does. It says your average is 210. Wait a minute. I know how averages work, and it's not going to be 210. Right? It should have been some number in the middle of all those numbers because it should be the average number. So what happened? Well, if we look at this, think about order of operations. We said add, divide. Well, it looks at that and says, well, the first thing I'm going to do is divide because divide comes before addition in the order of operations. So the first thing it did is it divided 91 by 3. And it got like 30.33333, right? 30. And then it added that to 95 and 85, which was 180. So it added 180 plus 30.333 and got 210. That is not how the average works, right? For an average, we need all these numbers to be added together first. So we should use parentheses. So because parentheses comes first in our order of operations. If we do that, now it's going to say, oh, the first thing I'll do is I'll add these together. Then divide by 3. Order of operations. If we didn't put parentheses, the first thing it did was the division. So let's run it now. Oh, look, the average is 90.3333. That looks much more correct. It's got to be some number right in the middle of those. I can believe it would be 90. I cannot believe it would be 210. All right, that's great. Order of operations. If you need to do something like this, make sure you put parentheses to force it to do what you want to do first. Parentheses can help us a lot in programming. All right, let's look at this one. Changing a variable's value. Define main. We're going to set x equal to 5. And then we're going to print the value of x is 5, right? And that's what it's going to equal to. And then we said take whatever x was and add 1 to it and make that the new x. And it's going to print again. Here's what x is. So let's run this. The value of x is 5. The value of x is 6. So this is a nice way to keep count of something. Every time something happens, you can just add 1 to your count. We're using x as a counting number. And we're to add 1 every time something happens, right? So we can take a variable and change the value, however we want to do. Make changes to the code so the value of x is increased by 10. Okay, we could say x equals x plus 10. Then when we run it, it goes from 5 to 15. So that's pretty handy. That's pretty convenient. We can use that in different things as we get farther and farther into our programming skills. Let's look at this last slide here. Calculate meal cost. Define main. The entree costs whatever it costs. The drink is going to cost this much. The tip is going to be this much. And this program should calculate the meal cost. So the meal cost will be, and all that. And then calculate the meal cost with the tip, total cost of the meal, and then we'll print the total cost at the bottom. So none of that is done. So we need to fill these in. It says write a program to calculate the total cost of a meal, entree, drink, and tip. Assign a value. If the tip is 18%, use the decimal 0.18. Right, because if we don't put that, it'll multiply it times 18, not 18%. So let's say we go buy an entree and it's going to be $12. And we'll make it a float value because we want it to calculate floats. And the drink is going to be like $2.99 because that's about what drinks are nowadays, or $3.49. They're crazy. And we're going to leave a 15% tip, 0.15. Now we need to write the command to calculate the meal cost. Now this is not with the tip. The tip's down here. So how much does our meal cost? It costs the entree plus the drink. We don't have to put 12 plus $2.99 because maybe the entree is going to change. Oh, wait, don't give me that. Give me this instead. I don't have to change that every time that changes. This just adds whatever the entree is equal to plus what the drink is equal to, which in this case would be $14.99, right? 12 plus $2.99. And then the tip, we'll take the meal cost because we've already added those together. We don't have to do it again. We saved it right here. Meal cost. Oh, I need to capitalize the C because it's capitalized right here. Meal cost times, and, oh, well, let's do this. The meal cost, I'm going to do it this way. Meal cost plus parentheses, the meal cost times the tip. Oh, where's that? Tip. So we're adding the tip to the meal cost. We have the meal cost plus the meal cost times 15%. and that'll be the total cost. Let's run it. Oh, I didn't capitalize it. Right there. It says meal cost is not defined. This is a different variable than with the capital C. Capitalization matters. Total cost of meals, $17 and 0.2385 or 24 cents. Perfect. If we want to check to see if it's something that we can make sure it's calculating right, we just make it 10%, and we can print both. Print meal cost and print total cost. Right, just to check it. So the meal cost was $14.99. Oh, let's print what the tip was too. Print tip. And we said it's going to be 10%. Tip is meal cost times 10%. Yeah, $1.49 should be 10% of $14.99. So we can test it to make sure it's working, and then you add those together and it's 16.49. So once we add those together, we say, okay, now I can change it to 15%, and I know it's working. So this is the correct number.
So glad we have this.
We can play with the numbers. All right, let's look at page 5. A new function, STR. There's a new function we need to know because we'll need this in our program next week or whatever week. I think it's 2 weeks. Eventually, you'll find you're printing a zillion different statements, right? It'll get confusing and makes your code long and messy. I mean, goodness, look at all this. Ooh. On level 17 of your Epic game, your score is 1337, and you have 4 lives left with 84% energy left. And look, that's 9 lines of code that are printing, 9 print statements. We can do better with the string function. Python will not let you concatenate string literals and numeric values. So what can you do? Like if I want to print numbers and words on the same line, Python's like, I don't know how to print numbers and words. But there's this function called str, string. So let's say we've got the score of 1337, and we want to say your epic score is 1337 on the same line. We want to just concatenate. I want to print it all in one line, so I don't have to use 9 lines. This will give you an error. You're trying to concatenate a string literal with a number, 1337. So how can you make it work? Turn the number into a string. If we turn it into a string, it'll print it. It'll say your epic score is 1337. So how do we turn the number into a string? We use this string command. And that score, which was equal to 1337, was a number. When we do this print statement, say, look, I know it's a number, but just act like it's a string and print it anyway. And then Python said, oh, okay, I can print a string with a string. I couldn't print a number with a string, but I can print a string with a string. So if you're telling me this number is just a string, I'll print it. So let's look at this activity down here. Number 1, number 2, number 3. Again, total points. Now this time they added the total points together and saved it and then divided it by 3. So I didn't have to worry about order of operations. Because the first thing it does is add them together, and the second thing it does is divide them by 3. Then we said your stats, total points, average points. When we run it, 271 total points. We add those 3 tests together. The average is 90.333333 when we divide it. Now look at this. We got several lines of code. So how can we change that? Let's look at the next slide. Same thing. Same 3 numbers. Still add them together. Still divide them by 3. But look, now we said we want to print total points equals plus total points on the same line. When we run it, though, it says I cannot print string values and integers on the same line. Well, if we go in here and say, okay, treat this number like it's a string literal. Look, I know it's a number, but act like it's not. Treat it like it's a string, and then you're just printing a string and a string. And it says, oh, okay, I can do that then. Total points, 271. even though it was a number, it treated it like a string and just printed it all in the same line. Which means we could do the same thing with average, right? Plus string, oh, I didn't mean to capitalize it. String average. So I don't need this print statement now. Average points equals plus string average. Printed on it. Now this looks a lot better. We're cleaning it up a little bit. Printed on the same line. Total points 271. Average points 90.3333. That string function, we're going to use that a lot this year. So make sure you come here and practice. Go to page 5 and practice. Let's look at their last one. Oh, this is when they want us to do average here. We already did it. Plus string average. And I close my second parentheses. Oh, bad error in line 16. Did I miss a parentheses? I have an extra parentheses. Oh, I need another one. I got 3 open. I need 3 closed. There we go. 271, 90.33. But yeah, I would practice on page 5 with that. All right. That is the end of the lesson. Let's go look at the assignment. 5 questions. What's the purpose of the string function? Read this code. What is it calculating? In Python, parentheses are used in calculations where the order of operations affects the outcome. True or false? Christina wants to calculate the average age of her 3 program users. Which one of these expressions will do it correctly? Read this code. It's written to calculate an average. Which line has an error and why? Which line? One of those is wrong. So that's it. 5 questions this week, guys. Pretty simple. 5 questions. Just make sure you understand what's going on in the lesson. Go practice those Python guided activities, especially page 5 when you're using the str command, the string command. So make sure you know how to use that. We will be using that in our programs coming up this unit and pretty much for the rest of the year, because there's lots of times we want to print numbers with string literals. So, all right, I will let you go.